when all the mean legends occupy the corner of the square planar or the plane of the paper. When these chlorine legends are on the same side, the type of isomer is known as cis, while in this compound, when the chlorine occupy the antiposition and or we can say they are to opposite to each other, the form is known as trans. This complex shows blue violet color, while this transform shows green color. Dichloro tetraamine cobalt, its oxidation state 3 ion. This is an example of the octahedral complex in case of geometrical isomerism. Another type of stereoisomerism is known as optical isomerism. It is actually, keep it in the mind, which type of coordination compounds or the complexes show optical isomerism. It is due to lack of symmetry in the complex. If you can remind, when a compound or the complex or the molecule or the object is lacking in symmetry, any type of symmetry elements, only those compounds show optical isomerism. In particular, this case, the optical isomerism is due to the lack of symmetry in the complex. Optical isomers are mirror images. And which type of mirror images? Which cannot be superimposed. The complexes with coordination number 6 and having bidentate legends provide example of optical isomerism. We can take an example. Tris oxalato chromate 3 ion. Keep it in mind that oxalate ion here is bidentate. Okay, so it can be shown in octahedral compounds like chromium on the center position of this plane of the paper. Now, how the different 3 oxalate bidentate legends are linked to this, it can be shown as like this. Bidentate means there are 2 ends of the oxalate ions which coordinate with chromium metal, first from this side and the second one from above the plane, and the next one is oxalate ion in this way when below the plane, and one of the end of this oxalate ion coordinate with this, and the third coordinate like this. In another case, it can be like this. Above the plane and to this end, while the next one is below the plane and to this corner, and the next one is like this. If we observe these two compounds, what we found that they are mirror images of each other, and these the mirror image cannot be superimposed on the object or the molecule or the ion. So this type of isomerism is known as optical isomerism. Thank you.